How are the following conversions carried out? How do you change one compound to the other? Because this is something which is very important in general practical organic chemistry in industry also. So if you are given, say, propene, and this propene you have intentions that you would convert to, well, propanol, propane 2-ol. You have added H and OH. How would you do that? Yes, this is something which is called as hydration of alkene. Hydration of alkene can be done in many ways, but the simplest of them is H plus H2O. For H plus, you could add H2SO4. Just take dilute sulfuric acid, add it, and you react it, and there we are. You simply get propane 2-ol. As simple as that. Yes, this is Markov-Nikov's addition, and this is what you get. What about benzyl chloride to benzyl alcohol? This again could not have been simpler. Sorry. We have to have benzyl chloride, yes. Do you know, you're treated by aqueous image. We want substitution. Take OH minus, which is a strong nucleophile, classic SN2 reaction. And in one step, you get CH2, OH, and chloride is kicked out. You get benzyl alcohol, as simple as that. Ethyl magnesium chloride to propane 1-ol. Oh my God, now there is some interest. CH3, CH2, MgCl. This is ethyl magnesium chloride, and you wish to convert this to CH3, CH2, CH2, OH. What extra have you added? Well, you have added one carbon and one oxygen. Hydrogens are of course there. How do we do that? We increase number of carbons and hydrogens. Typically, aldehydes and ketones give addition reaction with Grignard reagent. So the idea you get is, you add something which has one carbon and one oxygen. One carbon, aldehyde or ketone with one carbon, that is formaldehyde. There is no ketone, aldehyde only. So let us try HCOH. Okay. And if we do this addition, what happens? Attack! And suddenly you find this minus charge goes and attacks this carbon. Okay, what do you get? You get CH3, CH2, and there's something new. There's a new bond here. And I get CH2. So this is the old, this formaldehyde CH2. Pi bond jumps on this side, and I get O minus here, which is fine. This extra lone pair, this pi bond has jumped. This lone pair is extra, which comes here. I have CH3, CH2, CH2O. It is minus. That's okay. Just add H plus. Mild. Even if you add water, it's fine. O minus will take away H plus, and you will get CH3, CH2, CH2, OH, which is propane 1-ol. Increase one carbon and get a primary alcohol. How do you do that? Add an aldehyde. Extra one carbon, add one carbon aldehyde, and what is that? Formaldehyde. You get that. Methyl magnesium bromide. Well, find CFCH3, MgBr, methyl magnesium bromide, and you want 2-methyl propane 2-ol. This is propane 2-ol and 2-methyl. You want tertiary butyl alcohol or 2-methyl propane 2-ol. How do we get that? Now, I just have CH3 group. Okay. What do I do? There are many ways in which I could do that. Like, if I just imagine, just come one step behind. And, well, if you had something like acetone. Acetone? Acetone. And how do I get the idea? See, this is 4 carbons. Methyl has 1, subtract it. So let's have something with 3 carbon atoms. An aldehyde or ketone with 3 carbon atoms and that too OH as tertiary in middle. So most likely this should be a ketone, and the simplest ketone we know it is acetone. Let us see if they react. Yes, they do. Attack, shadak, like this. And I get a new CH3, a new bond like this, CO minus. This is the old one. This is the old structure. I get a new CH3 added. I'm pretty close. What do? I just add H plus. Just add an acid. Dilute acid also is fine. There we are. We get that. You know, I can tell you a secret also. This is just one of the methods in which you could have done this. Are there the methods? Yes. In case you are allowed to use esters. What? I'm saying in case you are allowed to use esters. There are also ways in which you could have got an ester to work for you. What? Yeah. If you're confused, let me demonstrate this for you. Not just esters, you also could have had something like carbonyl chloride. I'll begin with a simpler looking substance. Let us say you treat this with ClCOCl, which is phosgene. There is also a gas called phosphine, very poisonous, pH 3. A very similar name, phosgene, is a different gas. It is also called carbonyl chloride, very poisonous once again. But then, in case we can use that as synthesis, let's try. What happens? Attack. It happens once. See, when there is an attack, this is what you get. There's a new bond with CH3. Yeah. And the moment methyl group donates a lone pair, this pi bond jumps up and it goes on oxygen. You can see 2 lone pairs here. Now it has become 3. There's a third one extra. Can you see that? Yes. Now, the moment oxygen gets so many lone pairs, oxygen also is not very happy. Come on, lone pairs, you're so stupid. Somebody attacks and you just jump on my head. Go back, go and fight. One error. By mistake, I just wrote methyl. This is chlorine, not methyl. This is Cl. So lone pairs try to push back. And when they push back, they have to push something out. They push it out. Oh my God, what do you get? You get CO is back again. Chloride is out. You have methyl and you have Cl. So one Cl has been substituted by one methyl. Okay? And then again, because it is the same mixture in which reaction is happening, this is noticed by another molecule of same Grignard's reagent. Once again, attack. It is in full attack mode. I get CO, CH3, Cl, yes. And this new CH3 again gets attached and it pushes up a lone pair like this. Carbon is again very mad. Come on, have some shame, have some sense. Get back and get out. Fine. What do I get? I get CH3. CO, CH3. Oh my God, you have done it. You have managed to generate acetone. Yes, we have managed to generate acetone. And then the same mixture, we simply have excess of CH3 MgBr, that's it. So what we do? We take a third mole of CH3 minus. Attack once again. We have enough. There is no dearth. And this is what we get. One new bond, O minus. There we are. This time there is no going back because methyl groups are very difficult to push out. Chloride was a good leaving group. It could have been pushed out, not CH3 minus. It is there to stay. It says. It stays and just acidify that. Good enough? Yes, good enough. And you get tertiary butyl alcohol, a more fundamental and a more beautiful way to get tertiary butyl alcohol.